and I'm a co-chair with Mike, who's on the call you'll be hearing from later, of the Toxics Free Great Lakes Binational Network. And I'll be facilitating the session today. Our purpose today is to really talk about developing a strategy on how we can work binationally to deal with the PFAS threat to the lakes. And we, of course, can never expect to get through the whole strategy in this one call, but it's to start it, to make some suggestions about what next steps might be in terms of following up to it, so keep that in mind. We will, however, be having a couple of presentations before we get to that stage to put people on a bit more of a common ground, because there's some people who've been working really hard on PFAS and others who haven't as much but are interested and want to get involved. So we'll have two presentations at the beginning before we get into the discussion. This session is sponsored by the Canadian Environmental Law Association, and it's a legal aid clinic actually in Ontario that is focused upon helping the sort of disadvantaged communities, poor, etc., to be able to really use the laws and the legislation in Canada and Ontario to protect their communities, and also really focused on working for reform to better protect everyone in the Great Lakes and on the Canadian-Ontario side. But CELA has also been heavily involved for years on binational work, and toxics is certainly one of those. There's a project that CELA has, which is the Toxics is the Healthy Great Lakes Network that is a project of CELA that is also part of this project, the Healthy Great Lakes Project. It's also sponsored by the Toxics Free Great Lakes Network, and I mentioned that Mike and I are co-chairs of that, and it really focuses on the Great Lakes Water Quality Agreement and Annex 3, which is the Toxics Agreement, in terms of keeping an eye on what the governments are doing binationally to protect our lakes, and so really promoting that. The other one that's co-sponsor is the National Wildlife Federation, and particularly the Great Lakes Office. And it's worked for decades on Great Lakes work, as well as obviously countrywide work in the US on a wide range of issues. And you'll be hearing from Mike later, who's a member of that organization. So what I'd like to do is turn it over to April, who's our expert on running Zoom. It seems that she's probably spending all of her time on these now, at least an awful big percentage of it. So she can tell us about how the program is going to operate in terms of the use of Zoom.
Sure, thanks, John. So for those who aren't familiar with the Zoom system, if you hold your mouse over the bottom of your Zoom window, you'll see a series of options there. You can click on the participants link to have a look at who else is in the meeting with us today. You can click on the chat box to be able to access the chat feature today. And if you want, there is a reaction button. You can do a little thumbs up or a little smiley face just for fun. So what we're going to be doing today is asking you to keep all of your lines muted, because we have over 20 people on the call and we want to protect the sound quality of the call. So we'll ask you to keep your line muted, and we'll ask you to keep your line muted throughout the presentations this morning. Once the presentation portion is complete and we move into our discussion period, we'll start taking questions through the chat box. So you can either type your question in the chat box, or you can simply put in an asterisk or say, I'd like to ask a question, and we'll then call on you to unmute your microphone and share your question, or unmute your microphone and respond to a question if you have a thought. So you can say, I would like to speak, put in an asterisk. You can also use the hand raising feature if you prefer that. That's an option in your menu as well. But like I said, the chat box is probably the best way to do that. And we're going to hold all of those questions until after the presentations are done. Was there anything else I was to touch on, John, in terms of the Zoom logistics, or did I get all of them?
Well, recording.
Right, we are recording today's session. Thank you, John. The recording of the presentations will be shared on our website later this afternoon for everyone's reference. The recording of our discussion, however, will not be shared. It's just for our own internal references. If there's nothing else in terms of Zoom logistics, I can start with a land acknowledgement. Okay, great. So I'm calling in today from Guelph, so I'll share the land acknowledgement that I like to use for Guelph. I'm sure we're all calling in from different parts of the province. And beyond the province, I know, and the US, and all of our 8 Great Lakes states as well. Thank you. So in Guelph, we are situated on treaty land that is steeped in rich Indigenous history and is home to many First Nations, Inuit, and Métis people today. It's the ancestral land of the Attawandaron people, and it's the treaty territory of the Mississauga of the Credit First Nation of Anishinaabe. Our neighbors are the 6 nations of the Grand Watershed, and we're grateful for their stewardship of this land through the ages, and we commit to respectful relationships with our Indigenous neighbors and with the land. John, should I go into the poll questions?
Yeah, go ahead and do the survey questions.
Great.
Yes.
Okay, we have a couple of quick polling questions to get a better sense of who's on the call with us today. So if you can let us know what sector you represent first. So you hopefully will see a little poll window popped up on your screen there, and you can click.
It's
great. There. Thanks, John. I'm going to leave that up for about 5 more seconds because there aren't that many of us all on today. All right, so it looks like about half of the people on the line have voted. All right, so I'm going to just share that back with you so you can see that of the people who've answered the poll today, 10 are with environmental organizations, 1 member of the media, and 2 academic or students. Next up, I will move on to our next question. You can let us know what country you're phoning in from today. See, everybody's so much faster now. All right, just a couple more seconds here. And we'll share that back with you. So the US is winning with 10-4 between the US and Canada in terms of our participants today. And then more specifically, tell us about what watershed you're in. And I apologize, I typically do this for Ontario. So I did add in the Lake Michigan watershed, but if I missed your watershed, I do apologize. I think this should catch most of us, but it was pointed out to me today that I need to add the Ottawa River watershed to this, at least for our Ontarians. So I'm sure there are some in the states that I'm missing. I'll give this a few more seconds. There we go. So we have pretty even distribution. No one from Lake Superior today and no one from the St. Lawrence. And obviously I did miss a couple because we've got 3 in that other category. All right, and the last question that we'd like to ask you before I pass it back to John is just what sort of work your organization is doing on PFAS right now. And you can pick more than one answer here, but we want to know if it's a key focus for your organization, if you're just starting to learn about it and are interested, if funding is a barrier for you, otherwise you would be engaged, or if you're not working on the issue at this time. And again, if you need to pick more than one, that's fine. So I'll give people a few more seconds because this one's a little bit more complicated. Okay, I think most of our votes are in. So we'll show this back. So it looks like 7 out of the 11 respondents have said it's a key focus for our organization. A couple who are saying that they would be engaged if it weren't for funding as a barrier, some interested in learning about it, and one saying they're not working on it at this time. Okay, so with that, John, I think I will hand it back to you.
Okay, thank you. As I said earlier, we're going to begin by having 2 presentations. One is from Mike Murray, and Mike is with the National Wildlife Federation, the Great Lakes office, though he doesn't live in the Great Lakes office or in that community. And he's a staff scientist and has been for over 20 years with a lot of experience on working on toxics issues in the Great Lakes. We'll then hear from Bev Thorpe, and she's with Clean Production Action, is one of the groups that she works with and volunteers with, and has done a lot of PFAS work for the Canadian Environmental Law Association, major research that we did at CELA in terms of the state of the law and the state of the knowledge on the Canadian side of the Great Lakes. So we'll have those two presentations, and we'll come back very quickly after that for one more piece from Mike Murray, when he'll talk about the status binationally in terms of the government's work. And then we'll get into discussion after that. Okay, Mike, I guess we're ready for you.
Alrighty, thank you, John. And as John indicated, as indicated in the title here, I'm going to be providing actually a very brief overview of science and policy issues from a U.S. perspective on PFAS in the Great Lakes. Next slide, please. So this may be an introduction to most everyone on the call, but real briefly in terms of an overview of PFAS themselves, or per and polyfluoroalkyl substances. There are over, this is a large family of compounds, over 4,000 individual compounds within this family. There's actually some differences of perspectives as to even just the acronym, whether, for example, when we're talking about multiple compounds, if we should have the S indicating plural, or if it's inherently plural because we're already talking about per and polyfluoroalkyl substances. Government agencies seem to typically just especially in the US, just not use the S for plural, whereas in the scientific literature, it's more common. So anyway, just something to note when you see this term. A couple of the key PFASs are, or basically the structure is indicated here in this figure. Basically, you have a linear organic compound where fluorines are either replacing all of the hydrogens that would otherwise be present, in which case it's a perfluorinated compound, or some of them, in which case it would be polyfluoro compound. And two key examples are perfluorooctane sulfonic acid, or PFAS, PFOS, which is shown here, and perfluorooctanoic acid, PFOA, in which case you don't have the sulfonic group here and you would have a carboxylic group instead here. So it's, in terms of the pronunciation, you'll note that this PFAS is this specific individual PFAS compound. And I like to use PFAS when we're talking about the family of compounds, just to distinguish, to indicate that we're referencing the whole group of compounds or some subset of them, versus PFAS is this specific individual compound. An important one, but again, just one of thousands. There have been multiple uses of PFASs historically since they were first developed in the 40s. You can see this handy schematic here from the Green Science Policy Institute, all the different possible applications, including carpets, basically water repellent, stain repellent, fabrics, materials, and outdoor wear, couches, furniture, as well as in firefighting foam has been a quite significant use at military bases, airports, and so on. They're really inherently persistent, in particular because of this carbon-fluorine bond, which is very strong. They just don't readily break down in the environment. And actually, sometimes when they do break down from one PFAS to another. So just because it's been transformed doesn't mean that it's not still a problem. And so that's a major challenge that we have with these compounds in the environment. Again, they're inherently persistent, most of them. They're also many bioaccumulative and many toxic, and thus PBT. And I'm sure folks on the call have worked with a number of other PBT chemicals, PCBs, and mercury and others in the past. So this is yet another example of this problematic class of chemicals. As I just mentioned, there's the precursors and degradation products we need to be worried about or concerned about, as well as production shifts. So these two compounds here were of significant use historically, but in the US, they were phased out really in the past 15 to 20 years. In the meantime, though, industry has switched to producing and using a lot of other PFAS compounds that, again, may be problematic. So just something we need to keep in mind. Next slide, please. In terms of thinking about cycling of these compounds, yep, here we go. A real simple way to think about it is here. They're producing the compounds or using them in products. They can be released into the environment, circle between the air and water, soil, and so on. Ultimately lead to exposures in fish and wildlife and other organisms in the environment, and as well as to humans. So when we think about human exposures, a lot of that could come from the environment, say from water, drinking water, could be coming from if we're consuming, say, fish or wildlife, but also not really indicated here, but we can actually be exposed directly from PFAS containing products, cookware, jackets that start kind of falling apart and flaking off and that type of thing. We can be exposed to the dust and other materials that contain PFASs. So it's really complicated, even just looking at the possible exposure routes for PFASs in humans. And all of this has implications for the intervention points that we might proceed along, whether intervening early on in the production phase or a little bit later on before exposure, say, to humans. Next slide, please. In terms of PFAS in the Great Lakes, so a lot of this draws on the report that my colleague Ode Salim and I put together last fall on PFAS in the Great Lakes. They've been measured for a number of years in multiple media in the Great Lakes. And when you look at, say, the sediments in the Great Lakes, typically we've seen researchers seeing higher concentrations more towards the southeast, say Lake Erie, Lake Ontario, and as folks know, generally more kind of industrialized or more heavily impacted in many ways compared to the other Great Lakes, especially say compared to Lake Superior. The Fish and Wildlife Service in the US has done a number of studies on tree swallows, and just showing the levels you can see here from this map here, showing much higher levels in certain areas where they've sampled up near Duluth in this here near Escoda, Michigan, former Wordsmith Air Force Base, along the Huron-Erie corridor. So we can see pretty wide-ranging concentrations in different organisms in the few studies that are more systematic like that. And near a number of these facilities, we have elevated groundwater levels. And it's really only been more recently that we've got systematic monitoring that's going on for these compounds throughout the Great Lakes, including in the State of the Great Lakes report, of which the summary was just recently released. And the technical report, I assume, will be available later this year with more details. Next slide, please. In terms of human health concerns with PFAS, as I mentioned, there are a number of different possible exposure routes. Drinking water is often a major pathway, although actually food ingestion has been found to be quite common as well in the studies that have been done to date. A number of different effects have been documented. Basically, we can either do epidemiological studies or toxicological studies, say on lab animals, but these types of effects have been seen, in particular from the epidemiology studies, such as the C8 study in West Virginia, in relation to a DuPont plant there. There are also, and this actually, the schematic down here shows the wide-ranging exposure levels we can have in, say, the blood levels for PFAS amongst individuals. So, can be very high amongst workers, high in communities that are near, say, contaminated facilities, and then the general population might be down here as in terms of the averages. But again, the higher extremes within these populations can be still quite elevated and potentially of health concerns. And there are also equity and environmental justice issues that may be present for PFASs, although we really don't have good data on that for the most part around the country. There's a lot more work needs to be done. Next slide, please. In terms of ecological exposures and effects within the Great Lakes, these compounds have been found in a lot of different fish and wildlife is indicated here. Some of them can actually biomagnify, so they get taken up at lower levels of the food web and then increase in concentration, say from forage fish to predator fish, maybe to some of these predator birds such as eagles, osprey, and so on. There can be wide geographic differences, as I just showed, say, for the tree swallows. In terms of effects, the field studies have shown reproductive effects for the tree swallows associated with increasing PFAS exposure. And also it gets complicated too, because like so many of these other chemicals, these organisms and people aren't just exposed to PFASs, they're exposed to other contaminants as well that can cause some similar effects. So it can be challenging to tease out what's specifically due to PFASs versus other compounds. But it does seem that they are having these reproductive effects in some populations, and there are concerns with other species as well, such as great blue heron and even potentially bald eagles. Next slide, please. So in terms of the federal legal framework on the US side, these are just a few of the statutes here that are really quite key as we see them in terms of addressing PFASs. And this again gets back to this schematic of where PFASs, how PFAS enter in the environment, how they ultimately lead to exposures. So some of these statutes here are dealing with this more on the left side of this, Toxic Substances Control Act, whether a chemical can even be produced or restrictions on its use and production. There have been a number of significant new use rules developed for certain PFASs through the years. None have been actually formally banned under TSCA, so that's important to note. This law here is under which the Toxics Release Inventory Program is run, in which industries that are using particular chemicals have to report them to the government every year. And just last year, 160 PFASs were added to this inventory program in the US. So that reporting starts this year. And actually, I saw just this morning that EPA had in the Federal Register a formal notice that it's actually going to be 172, I believe, individual compounds to be reported through the inventory program. And then other statutes here, you can see we've got for Superfund sites, screening levels, remediation goals in place for 2 of the PFASs. Clean Water Act, there's been very little that's been done as far as I know, through Clean Water Act to address PFASs. There's possibility for action going forward. Safe Drinking Water Act in the US, there's a proposal that was just recently put out concerning potentially regulating PFAS and PFOA. We'll see what happens with that going forward. This aspect here is more kind of later on in this process, right before it gets to humans, say from drinking water supplies, what's the acceptable level of these contaminants in the water. So this is what's happening at the federal level. There's additional work going on at the state level that we touch on in our, spend a lot of time on actually in our report from last year. Next slide, please. Just to wrap up, a few general thoughts on what we need in terms of the science. Really, there just needs to be more systematic environmental monitoring and human biomonitoring, and in particular, exposure and effect studies. There's just so much work going on PFAS now around the world, in other countries and the US and Europe, China, but still a lot we still need to learn. And again, I think in particular on the ecological end, what are the levels in wildlife? What are the the health concerns for those wildlife exposed? On policy, there's a lot more that can be done at the federal level in the US. As I mentioned, the states are doing quite a bit on their own, trying to move forward where they can, in sometimes ahead of the federal government on setting, say, safe maximum contaminant levels for drinking water. But in general, I think there's a need for a more precautionary approach, really looking kind of at the left end of that diagram I showed for where we can intervene in the process to try to ultimately reduce this problem, whether that's phase outs, other ways to reduce the presence of PFAS in the environment and the health and ecological concerns that they pose. With that, I'll turn it back to Bev.
Great, thanks Mike, and greetings everyone. I would like to now speak about the Canadian context for PFAS binational work in the Great Lakes and some of the opportunities and challenges going forward. Here's a map of the drainage basin of the Great Lakes to give some context of the area we're speaking about. I should also add, we often talk of the Great Lakes St. Lawrence River ecosystem, which includes the province of Quebec to the east of this map, because of course the water flows down the St. Lawrence into the Atlantic. So as a former Montrealer, I always felt geographically part of the Great Lakes. I'm going to touch on 6 key points in the following slides. We'll have a quick look at what the Canadian federal government has done, as well as some good news from Transport Canada, followed by the situation that no provincial regulations exist for how PFAS is released into the environment, noting that pulp mills and paper fabrication facilities are not regulated at all in Canada or the US. Then I'll end with a discussion point on the presence of PFAS in consumer products. So my personal opinion is that I would characterize the Canadian regulatory response to PFAS as the problem has been dealt with, or more to the point, Canada doesn't have the same problem as the US because Canada does not manufacture PFAS nor have as many military bases and airports. Regarding federal regs, as you can see in 2006 and 2012, Canada regulated PFAS and PFOA and certain long-chain PFCs, but there are still exemptions for their ongoing use in firefighting foam and textiles. And as a reminder, as Mike pointed out, there's over 4,700, some say over 5,000 different substances in this class of PFAS chemicals. More to the point, the fluorinated substitutes being put on the market have little to no data on their use, toxicity, and chemical structure, and are not regulated or restricted in Canada. So we're seeing these new PFAS substitutes promoted for use in firefighting foam, carpets, textiles, cosmetics, and other industrial and product uses. However, as Mike pointed out, they're still highly persistent, and they're even more mobile in water, which is a big concern in the Great Lakes watershed. Health Canada biomonitoring results confirm PFAS and PFOA are present in all Canadian populations sampled. Well, here's some good news. A year ago, Transport Canada announced that airports are allowed to use PFAS-free firefighting foam. This Canadian initiative may be useful for US groups. Several states, including Minnesota and New York, have banned the use of PFAS chemicals in firefighting foam for practice runs, but airports in the US are regulated by the Federal Aviation Administration, which currently requires all US airports to use PFAS-based firefighting foams. The good news is that FAA Reauthorization Act of 2018 requires them to change their rules and stop mandating the use of these products by 2021. And I know there are many US groups working to ensure this happens. PFAS foam is also used on military bases, but in December 2019, the US Congress directed the military to phase out PFAS in firefighting foams by 2024. We have no such directives here in Canada. Recently, Clean Production Action released Green Screen Certified Standard for firefighting foam that eliminates not only PFAS, but other chemicals of high concern. And we're seeing, we currently have 4 to 6 different products that are currently certified. In Health Canada, drinking water guidelines, as you can see, I've put little X's and green check marks where I consider things that are good and things which are huge challenges. In December 2018, Health Canada published guidelines for Canadian drinking water quality for both PFOA and PFAS. The Canadian government's maximum acceptable concentration for PFAS in drinking water is 600 parts per trillion. Compare this to the US EPA's lifetime health advisory of 70 parts per trillion, which many say is way too high. In the Great Lakes Basin, Michigan, Minnesota, New York have proposed, and others have proposed or adopted stricter drinking water standards or guidelines after conducting their own analysis of limits that would be most protective of public health. So I just wanted to give you 3 examples to show the disparity of these different guidelines in the Great Lakes Basin. Health Canada notes that water utilities should sample source water for drinking water, particularly if they are impacted by firefighting training areas, military bases, airports, manufacturing sites, and/or waste disposal sites. And they note that conventional treatment is not effective for PFOA or PFAS removal. However, as of today, neither Ontario nor Quebec have legislated provincial drinking water guidelines for any PFAS in the Great Lakes St. Lawrence River ecosystem. There's very little, I would say there's very little or very low public awareness of PFAS in Canada. We don't know where contamination sites are or where monitoring may be conducted. If you go online and do a search, you will see that the Canadian government has published fact sheets and updates on the work that the federal government is doing, again, to regulate these PFAS, PFOA, and long-chain PFCAs. But there are no location-specific maps that would help communities identify the monitoring location and results for the presence of these and other PFAS in drinking water or groundwater. In comparison, the states of Minnesota, Michigan, New York provide a range of public information, including online maps of monitoring and contaminated sites, drinking water advisories, point sources of PFAS releases, and actions underway to deal with stockpiles of firefighting foam. Even the US Department of Defense gives online PFAS information, but we have no such information dissemination here in Canada from the Ministry of Defense. So, opportunity for comparative info exchange. There are no provincial regs for reporting on monitoring or identification where we know PFAS is a potential problem, such as wastewater treatment plants, nor is there public access to any current monitoring of groundwater, wells, biosolids, or drinking water. There are no requirements for local industry to report on their use of PFAS or how much is released into the environment, nor do we know how much is released from local landfills in our communities. But what we do know is that according to experts in the Great Lakes, quote, the highest levels of PFAS are generally found in areas of Lake Ontario, the western end of Lake Erie, and the Detroit River Corridor. And urban areas are a significant point source for releases of PFAS into the Great Lakes, which I think about a lot as I sit here in Toronto. As far back as 2009, Environment Canada noted that large urban areas can act as diffuse sources of PFAS due to their use in industrial processes and consumer products, and recommend that management action should focus on prevention of pollutant emissions from consumer and industrial products. However, there is no pollution prevention requirements for all PFAS used in commerce. So thinking of products, and this great graphic is from the Green Science Policy Institute. Thinking of products, this could be one way to raise awareness of Canadians to this issue. Health Canada itself acknowledges that oral hand-to-mouth contact with consumer products, such as carpets, clothing, and upholstery, is a significant contributor for infants, toddlers, and children. But we have no product policy addressing this at all in Canada. It's interesting what is happening in some of the US states. For example, the California Safer Consumer Products Program has listed carpets, rugs, textiles, and leathers treated with any PFAS chemical as priority products for alternatives assessment and regulation. The city of San Francisco has banned the use of compostable single-use food serviceware containing PFAS as of January this year. Other programs, such as the state of Washington's Safer Products for Washington program, targets 5 entire chemical classes for restriction, including the entire class of PFAS. This would identify products that contain these classes of chemicals and determine regulatory actions. Brands such as Interface Carpets have phased out PFAS, and retailers such as Home Depot no longer sell carpets and rugs with PFAS. This applies both to the US and Canada. So I just want to leave you with this really good graphic by the National Wildlife Federation showing how PFAS gets into our environment. And I like this because it shows the many point sources for action at community level across the basin. I know you have the slides ahead of time, so I won't go into any in-depth on this graphic, but it does show multiple intervention points. And with that, I will now hand the final content slide over to Mike for a brief summary of actions currently being taken under the Great Lakes Water Quality Agreement.
Thank you, Bev. As Bev noted, there are opportunities to work together across the border on these chemicals and other chemicals in the Great Lakes. I'm sure everyone on the call is familiar with, and maybe has already been doing some work through the Great Lakes Water Quality Agreement, first passed in 1972, or first adopted, agreed to by the US and Canada, 1972, amended a few times in the meantime, most recently 2012. And with the new agreement, now there are 10 annexes, including Annex 3, that addresses chemicals of mutual concern. And those are chemicals that have been designated by the parties, by the two governments, as chemicals of concern within the Great Lakes that both governments should be focusing on. Also, there's actually a process for individuals, groups, like groups on this call, to actually nominate chemicals to be considered and adopted as chemicals of mutual concern. And that process has actually been pretty slow, as those of us who've been involved know. One of the ways that the broader community is involved is through the extended subcommittee of Annex 3, of which John and Faye and myself are members. There have been 8 of the CMCs, or groups of chemicals, designated to date, including PFOA, PFAS, and then the long-chain perfluoroalkyl carboxylic acids as a group. We're still waiting, actually, for a significant action plan or binational strategy to be developed. Actually, and the governments have already said they're not going to develop a binational strategy for PFASs in particular, unlike what they've done for the other CMCs. Because on the US side, they've argued that we already have a federal action plan and that should be enough. We'll just kind of apply that to the Great Lakes. those of us in the NGO community are not happy with that, because we see the whole purpose of the Water Quality Agreement is to develop, joint programs and activities to address these chemicals of concern in the Great Lakes. So we'll see what happens with that. We continue to advocate for it, but at the same time, we hope that there are other opportunities to work together, including through the Water Quality Agreement programs and otherwise, to try to address these problems, these PFAS problems in the Great Lakes. And that's what we actually hope to discuss now in the time that we have remaining on this webinar.
Okay, thanks Mike and Bev. Can we stop the recording then for this section, because this is the part that we're having as public.